Hey guys, my name is Alex and thank you very much for stopping by. Really appreciate your visit. And today I just want to solve this second Ruby coding challenge. I've been recording this 30 Ruby coding challenge in 30 days, which will be great because for each day I'm gonna solve a specific problem or a specific algorithm. And for each algorithm we'll have something new to learn. That's it. And to be honest, so just a reminder, it doesn't matter if you know Ruby or not, because this is not about programming language. This is all about programming skills, because you can just take the concepts here that you're learning here, and you can take the logic and apply to the language that you like the most. So you can just rewrite all of these things in JavaScript, Python, and Go and Haskell, whatever you want. The way, and just to be really honest here, the way that I want to solve this is the way that my mind works, which is I just take the problem and I start thinking about the problem. And right after that, I try to write a really ugly code just to get the job done. And after that, I start decorating code. I start putting some glitters onto that. So the reality is that for the first version, don't worry about code design, don't worry about readability, especially don't worry about performance. So I just want to get the job done. And even before you start reconsidering our virtual friendship, I just want to say that for the next video, for the next 2 or maybe 3 videos, I just want to rewrite these algorithms, or the way that we are going to solve this problem, in a better way. So we will have probably 4 versions of this same problem being solved in Ruby. And of course, by the end of the day or by the end of this week, we're gonna have this problem being solved in a Ruby way, which is a really opinionated way to solve this specific problem. So let's get into it. And even before going crazily into code, I just want to make sure that we are really on the same page. So I'm going to take my iPad here and I'm going to just take a few examples just to make sure that we can calculate what a prime number is. The first thing that I want to do is I want to take at least 4 numbers. Let's say that I have 4 numbers. The first number will be 5. The second number will be 4, and we have maybe 6 and 7. So that's it. And what I want to do is, let me change the color. What I want to do is I want to validate if these numbers are prime or not. How can we do that? The first thing is that a prime number is evenly divided by itself and by 1, which means that I know that 5 is divided by 5, and I know that 5 is divided by 1. Perfect. Now, what I need to do is I need to validate if I have another number that can divide 5. Okay, so let's say here we have 4 and 3 and 2 and 1. So we have all of the numbers between 5 and 1. So 5 can be divided by 4? No, it can't. 5 can be divided by 3? No, it can't. By 2? It can't. So that's it. Because we have only 2 numbers, the number itself and 1, this number is considered as a prime number. So yeah, check. Let's go to the second one, change the color again. Let's go to 4. 4, again, we know that it's divided by 4 and it's divided by 1. That's the definition of a prime number. But let's validate if this is divided by other numbers. Now it's time to validate all of the numbers between 4 and 1. So change the color again. Let's write 3 and 2. So 4 is divided by 3? No, it's not. Is 4 divided by 2? Yes, it is. So the problem here is that I have changed the color again. We have 4, 1 number, 2 numbers, and 3 numbers. And because of that, 4 is not a prime number. Let's go ahead and let's go to 6. Well, we know that 6 is divided by itself, and we know that 6 is divided by 1. Let's validate 5. 4, and the 3, and the 2. Okay, the same question over and over again. By 5, no. By 4, no. By 3, yes. Okay, so 6 is divided by 3. And if you go to 2, yes, it's also divided by 2. So change the color again, and we have now 2 numbers. And because, oh, I have to maintain the same pattern, so this is not green. So we have 1 and 2, now 3 and 4, which means that 6 is not a prime number. Perfect. And let's go ahead and I know that you got it, but just because we have 70 here, let's do the same thing with 7. It's 7, and now we have 1. Okay, and let's validate all of the numbers between 7 and 1. We have 7 and 6 and 5 and 4 and 3 and 2, and that's it. By 6, nope. 5, nope. 4, nope. 3, nope. And 2, nope. Which means that we have this is not the right color, so I'm kind of okay, this is the color. Okay, and we have 7 and we have 1, and because we have 2 numbers, yes, the number itself, and 1, yes, here we go, we have a prime number. And just a reminder, when I say that a number is evenly divided by another number, what I really mean is that, let's take for example 5, and I'm gonna try to divide 5 by 4, which means that this will be the product between 4 and 1, and the remainder value, which is this number, let's change the color. So this is the remainder value, or remainder result. So the remainder result is different from 0, which means that this is not evenly divided. So that's the point when it comes to a number being evenly divided by another number. And I want to give you this spoiler because we want to translate that into Ruby. When you are dividing a number by another in Ruby, and actually in many languages, you say 5/4, and you have this, result. But when you think about the remainder number or the remainder result, you are actually saying that you want to use a %4, which means that you are not interested in the value of the division itself. You are more interested in the remainder result, which in this case will be different from 0. Okay, so that's a spoiler because now we can go crazily into code. Here we go. As you can see, I'm still using the Repo-It, which is this amazing website. You can just go there and write your code snippet. In this case, I'm using this Ruby online compiler. As you can see here, I'm using the Ruby language, of course. So I just want to do 2 things here. The first one, I just want to create the array that we're gonna go through and iterate in order to validate which numbers are prime or not. And then I'm going to create the method which will be responsible for calculating all of these numbers. So let's get into it. I have this array which will be my local variable, and I'm gonna have a couple of numbers here, 4 and 5, 6, 7, 8, 9, and 10. Here we go. Now let's define our method in Ruby. Define the method name, which will be called maybe count how many, I can't spell it, how many are prime. Here we go. And it takes an array as an argument, of course. And an array, and I have this. Okay, here we go. So one thing that I usually do when I'm just starting, thinking about a problem is creating a lot of local variables. But later I try to remove all of them, just to organize my thoughts and organize my code here. So I'm gonna start by creating a total, which will be a local variable that indicates, the total. So this total variable starts at 0, and then I'm going to return that later. Here we go. Perfect. The next step is to define the way that we can go through each of these numbers and ask an important question. Are you a prime number or not? That's it. So in order to go through all of the numbers in this array, so I want to iterate over them, let's create a for loop expression. So you can easily do that in Ruby, by the way. For each item in my array, I want to do something. Here we go. Really, really simple. So actually, I have the first step here. As you can see, our array is starting with 1. And as you may already know, by definition, 1 is not a prime number. So I can just say to this for loop expression, hey Ruby, please go to the next and skip this number. Go to next iteration if the item is equal to 1. That's really amazing. And actually, if you're coming from Java or JavaScript or Python, you usually use continue. That's the same thing. And we can go ahead and now let's pretend that this number is 6. No, we have 6 here. So I'm gonna use, let's say, item here. This is a pseudocode, and 5, 6. And then we are not interested in 6 and 1 because by definition we know that a prime number is already divided by the number itself and by 1. So we are interested in the numbers between those numbers. So we are interested in 5 and 4 and 3 and 2, but not 1. Okay, not 1 and not 6. So I'm going to separate them. Well, if I want to go from 6 to 1, the next step is creating a while expression. So while, and you have this condition, do something. That's it. So you will execute an expression, evaluate some expression or something like that. So the condition here will be really simple. We are not interested in the number 6, but we are interested in a number smaller than 6. So what we can do here, we say, hey, and we want to go until 1. So that means that the number that we are evaluating should be greater than 1 because we are not interested in this one. So I'm going to remove this. Perfect. And we are not interested in 6. That's great. So these are the numbers. If you are evaluating the number 6, these are the numbers that you are more interested in. So while number is greater than 1, you can keep going. That's it. So the next point is, of course, creating this local variable because you don't have that yet. So the number will be, as I said before, if you pretend that the item, the current item, which is the current number, is 6, then the number should be 5, the number minus 1. So you will have the item minus 1, 6 minus 1, and 5. And you can go from 5 to 2. That's it. That's really simple. And then you will ask the first question, the first and actually the unique question. Well, are you a prime number or not? And you can just ask that question by easily doing this expression or this line. So if the number, this isn't a number, right? So if the number can divide the item and the remainder value or the remainder result, just remember, like we saw earlier in the iPad, if the remainder value or remainder result is 0, then you are not a prime number. Let's say that you are trying to, let's say here, you are trying to divide 6 by 2. The remainder number, which is a percent, will be 0. Which in this case indicates that this is a not prime number. So if this is a not prime number, I don't care about the next numbers. I just want to stop because I already know that you are not a prime number. So 6, you are not a prime number. I don't care about you anymore. So what I can do, I can just break out a relationship. So let's break this while expression. And this is great because when you use this break, which actually you can find in any programming language probably, you break this while expression and you can go to the next item in your array and you can evaluate your next item because now you are not worried about this number. That's it. So you break, but else if this number is not divided by, this item is not divided by number, then I want to validate and evaluate the next number. So if I want to evaluate, again, let's pretend that we are evaluating 6, which in this case will be 6 minus 1, 5. If 5 is not divided by number, I want to evaluate now 4. That's great. Let's go ahead and indicate that this number, which in this case will be 5, just pretending here, will be number minus 1, which in this case will be 4. And then this number is 4. 4 is greater than 1. Okay, and you can validate if item, which was 6, is divided by 4, which in this case, this is not divided by 4. So you can go to else and validate 3. And now 6 is divided by 3. Yes, so you break the relationship and now you go to the next item, which in this case would be 7. That's really, really simple. Let's move on and let's create another local variable. I know that sounds really terrible. Let's create a local variable called isPrime, which indicates that if the number is prime, right? So, and I'm gonna start that with a true value. And then when you have this line being evaluated to 0, you will say that the number is not prime. If the number is not prime, then I'm going to change this variable, this local variable, to false. So the number is not prime. That's very simple. And then we have this control if the number is prime or not. But once you just finish this while expression, and you didn't change the isPrime local variable, then you know that by the end of this while expression, you can evaluate this isPrime expression by asking if the number is prime or not. So if isPrime true, and you can just say isPrime true, then I know that I can get the total value, which starts at 0, and I can say total value plus 1, because I have found a number that is prime. So let's simulate something here. Let's say that the number that you are trying to evaluate is 3. So you have 3, and then isPrime is true, unless you prove that this is not true. And then the number will have 3 minus 1, which will be 2. 2 is greater than 1. Item is 3 divided by 2. This is not 0. The remainder result is not 0. Then you go to else. 2 minus 1 is 1. So this is not greater than 1, which means that you will end this while expression. And then I can just ask to the local variable isPrime, hey, are you a prime number? Yes, I am. Now I can calculate the total. That's very simple. And if I want to just execute this code, let's say that I have this puts, which prints out something on the console here, you will say count how many are prime. And of course, probably this will be executed wrongly. So I have this array, and then if we execute this, let me see, 9 should be okay. If prime, of course, yeah, that's the classic problem. You just forget something here and everything is wrong. So now, as you can see, we have 4. Let me see, we have 1 is not prime, 2 is prime, 1, 3 is prime, 2, 4 5 is prime, 3, and 7 is prime, 4. So that's it. The code is really terrible and ugly, and I don't even sorry, because that's the way that my mind works. First of all, terrible code, ugly code just to get the job done. Second, you can have a digestible code. Third, you can have a reasonable code. And maybe fourth, you're gonna have a good code design. And by the end of the day, if you really want, you can have some performance in your code. And that's it for today, and I hope that you have enjoyed one thing or two, and see you in the next video. You know, this kind of